Welcome to atomic structure. I'm hoping that this isn't the first time you're learning about the structure of an atom. We've all learned that there are protons, neutrons, electrons. There's this nucleus thing in the middle of your atom. But did you ever ask why? Now, even to this day, we cannot see atoms. I mean, sometimes people get atoms and like cells in their body mixed up. And they'll think, oh, we're really tiny, but we can see a cell under a microscope. Even today, we cannot see an atom under a microscope. Not even like the best, most powerful microscopes cannot see down to an atomic level. Cells in your body are made of billions and trillions and whatever comes after that. Lots of atoms. And one molecule of DNA has tons and tons and tons of atoms. So what we want to do in this chapter is kind of get an idea of why we think atoms look the way they do, and based on what evidence, since we can't see them directly, why do I think there's protons, neutrons, electrons, all that good stuff? And then eventually we'll see how that affects the property of different atoms. So we're going to go way back in time and look at different models of the atom that eventually bring us up to a more modern view of what we think atoms look like today. So way back in time, the Greek philosophers sat around. I assume they didn't have a whole lot to do. They didn't have laboratories or anything like that. So one Greek philosopher in particular, Democritus, pondered over the question, could an object be divided into smaller and smaller pieces? Or at some point is there a limit to the amount of times that I could maybe cut something in half? So if I had an apple, I can cut it in half. I can take the halves and cut those in half. Could I continuously cut that apple into halves? Or at some point, will I reach the smallest particle of apple possible? It's too small to cut in half anymore. That's kind of where this all came from. What is the smallest particle of matter? How small can I cut a piece of matter until I hit that smallest particle possible? And again, there's no experimentation here. There's no laboratories and beakers and Bunsen burners and all that good stuff. Democritus said, you know what? There's got to be a limit. At some point, you will reach the smallest particle possible. I'm going to call that smallest particle possible an atom. And technically, atom means not to be cut or cannot be cut. So he figures, okay, at some point there's a limit to the amount of times you can cut something in half. Eventually, you'll reach the smallest particle possible. It's too small to divide anymore. And that smallest particle possible we're going to call an atom. And I have to think, to us this seems logical. Back in the day, people thought these philosophers were completely wacko. But again, they didn't really have any data to support their thoughts. I just have this fabulous thought that matter can't be cut forever. Finally, one of the first scientists to actually do experiments with matter was John Dalton, an English chemist. The first one that's really credited with a lot of experimentation, especially experimenting with some gases and looking at properties of matter. And his observations led to what's called Dalton's atomic theory. Note that this is called an atomic theory. A theory is something that can be changed as new information is discovered. Even today, we call it an atomic theory. And there are constantly people working to perfect the model of the atom. We've got new and more sophisticated equipment and particle accelerators and all kinds of cool things that can break atoms into smaller and smaller parts. They are even smaller parts than protons and neutrons and electrons. They can further be broken into smaller pieces. So even today, what our most modern thoughts of when it comes to atomic structure are still called atomic theory. As new and better information is discovered, a theory can change over time. Okay, so we've got 5 theories or principles that make up Dalton's atomic theory. Numero uno, matter is made of, now you have to watch this word, indivisible particles called atoms. Alright, so we kind of agreed with these early Greek philosophers that, I do believe that matter can be broken down into smaller and smaller pieces. I'm fine with the word atom. The key word here is indivisible, not invisible. Sometimes people get that mixed up. They'll be like, atoms are invisible because you can't see them with the naked eye. Well, but they're there. They're not invisible. Obviously, we can see large quantities of atoms, like I'm looking at this screen right now, I'm looking at my computer right now. Indivisible, meaning cannot be divided. So he's going to agree with the Greek theory that, these tiny little particles called atoms, these are just the smallest particles possible. Indivisible. You cannot divide atoms. That might be making your skin crawl. Number 2, atoms of the same element are the same. Atoms of the same element are the same. Again, earlier we talked about the difference between elements and compound. The periodic table has approximately 120 elements. A sample that's made of all the same kind of atom. So as he looks at, let's say you have a sample of sulfur, and he's saying different samples of sulfur all have the same properties. So that must boil down to the fact that the individual atoms of sulfur are all the same. All samples of copper have the same properties. So the smallest particle of copper, the copper atom, they must all be the same. And again, you're probably thinking to yourself, well, duh. But back at the time, this was like, wow, profound. Number 3. This is a crazy one. Atoms of different elements are different. Whoa. Atoms of different elements are different. I hope you're sitting down right now because that probably just knocked your socks off, right? Wow! In other words, atoms of sulfur are not the same as atoms of copper. Because if I look at samples of these elements, which obviously have lots and lots and lots of atoms, but the samples have different properties. So that must boil down to the fact that the individual particles are different in some way. Wow. Helium atoms must be different than aluminum atoms. They have very different properties. Now you're thinking, like, hey, why aren't I in these science books? I could have said that. Alright, 4. Principle number 4, theory number 4. Atoms can join to form compounds. Atoms can join to form compounds. again, we talked about compounds earlier. A group of different atoms chemically joined together. Because again, now you say, well, okay, here's these compounds, and they have new properties. The property of carbon dioxide is not the same as carbon or oxygen. So I must be able to join these atoms to form compounds. In a compound, we have new properties. It's like, I'm okay with that thought. Yeah, you could mix atoms together, chemically mix atoms together, and form compounds with new properties. And finally, number 5. Atoms cannot be created or destroyed. Cannot be created or destroyed. Interesting. Atoms cannot be created or destroyed. Okay, so as you look through these 5 statements, again, some of it is brutally obvious, and you're like, oh yeah, I have no problem with that. But are there a few statements up there that are not sitting well with you? You're like, I don't know if I agree with that. And if you're saying, yeah, that's okay, excellent, that's a good thing, actually. Because again, we have way better data available to us today. We have much better equipment available. So these 5 statements were part of his atomic theory. And theories can change over time as better information is discovered. So as we look through these 5 theories, are there any that are bothering you? Are there any that are maybe not true today? They may have been true at the time. These were the statements that were part of the original Dalton's atomic theory. But there are a few that I have issue with today. Let's walk through them. Matter is made of indivisible particles called atoms. I'm still fine with the fact that matter is made of smaller particles, and I'm still fine calling them atoms. What about that word indivisible? Does that bother you? Can we divide atoms today? Yeah. You betcha. So I have a little problem with number 1. Yes, atoms can be divided today. Atoms can be divided. That's called nuclear. Okay, fission or fusion? I'm hoping you're saying fission. Fusion is when new atoms are formed. When we join nuclei, we fuse nuclei together to make a larger atom. Fission is where we split an atom. Yes, atoms can be divided. We get tons of energy from that. So I do have a little issue with number 1. And you can think about it too. Like, the atom itself is not the smallest particle, I guess the smallest particle possible. There are protons, neutrons, electrons. It is the smallest particle that has the properties of that element. You have to have the protons, neutrons, electrons all together to make the atom that has the properties of sulfur or helium or whatever it might be. But the individual atom itself does have smaller components to it. Atoms of the same element are the same. Are you okay with that? I think you have to kind of like look to your background knowledge here. Have you ever heard of isotopes? And maybe you're kind of thinking this and you're like, oh, I can't remember the word for it. What about isotopes? We'll talk about these later in this chapter. Isotopes are atoms with the same number of protons, but different, we could say different numbers of neutrons. And again, if you kind of think back to whenever the last time you studied atomic structure was, the number of neutrons affects the mass For example, there are different forms of carbon. You can have carbon with a mass of 12. Let's see if I can get a little more room here. If I look on the periodic table, carbon's mass is really close to 12. So there's something called carbon -12. And that's the most common form of carbon, like charcoal and all that good stuff. Carbon 12. There are other forms of carbon that are not as stable. So for example, maybe you've heard of carbon 14. That's the one that's radioactive. It's used in like carbon dating. We can look at the amount of decay in a sample, try to figure out how old it might be. Carbon 14 is a form of carbon. They both have the same number of protons, and that eventually we'll kind of learn that the number of protons identifies the element. And if I look at the periodic table, carbon has 6 protons. It's element number 6. These are both forms of carbon. Carbon 14 is just a little heavier. It's got 2 extra neutrons. Oh, well that's kind of like, and other objects come in different sizes, but they're the same object. You can have 2 elephants and one's bigger than the other. They're both elephants. They just have different masses. So I do take a little issue with statement number 2 about atoms of the same element are the same. Not necessarily. They can have different masses. And that comes from having different numbers of neutrons. And that's the topic of isotopes. We're going to get into that more later on. Number 3, different elements are different. I'm fine with that. Atoms can join to form compounds. I take no issue with that. But I think we kind of hinted at 5. Atoms cannot be created or destroyed. Well, I guess if you're thinking of nuclear fission, dividing an atom, you're kind of destroying it, I guess. It's not in the same form as it originally was. So let's take issue with 5. Nuclear. Let's put both of them, fusion and fission. So we got fission. Fission is dividing an atom, so you have some large radioactive unstable atom and it decays and forms smaller atoms. Fusion is when you take smaller nuclei and you fuse them together, you join them together, and you make a new element. A lot of the elements at the bottom of the periodic table, some of these synthetic elements, were created by nuclear fusion reactions. They don't occur in nature. You don't just go digging in the ground and come upon some californium. Oh, cool, I have californium growing in my backyard. Now it was formed in a lab by a nuclear fusion reaction. So can we create atoms? Kind of. We have to take existing atoms and join them together, but yeah, absolutely we can create new atoms. That's how different atoms were formed. And in the sun and the stars, we started with small atoms like hydrogen and helium, and they kept fusing and fusing together to make larger and larger elements. So all of those 5 statements above were part of the original Dalton's atomic theory, but now that we have better information and more sophisticated laboratory equipment, we can maybe take issue with a few of those theories that might not be true anymore today.